Pantheon, one of the most impressive buildings ever constructed, whose dome has stood for 2,000 years. The aqueducts of Rome supplying water to millions. In the Great Pyramid, a tomb built as an eternal resting place. These monuments are testaments to the ingenuity of ancient builders, creations that have stood the test of time, but there's a catch. They may hold secrets from a long-ago world that could help us solve today's problems. From self-healing concrete to earthquake prediction, what if the solutions to tomorrow's challenges lie hidden in the ruins of yesterday? I am the host, and this is our channel. And today, we are looking at ancient engineering that could save the world. First up, self-healing concrete. Do you remember playing with Legos as a kid? Of course you do. Who doesn't love Legos? You snap them together, and they stay together. Something falls apart, you fix it back together again. It's easy. So why then does our multi-billion-dollar infrastructure fall apart so easily? We've been using concrete for thousands of years, but our modern formulas aren't holding up well. In fact, according to the American Society of Civil Engineers in 2021, the United States spent $3.2 trillion on its infrastructure. By 2030, that number is expected to be closer to $4.6 trillion. The US spends about $2.4 trillion annually on healthcare. So in less than a decade, more money will be spent repairing and replacing concrete than on fighting some of the world's most dreaded diseases combined. The Romans knew a thing or two about making their concrete last. Roman concrete is still standing after 2,000 years because it was designed to survive time. A new study suggests that the ingredients used in Roman concrete may be key to solving this problem. Volcanic ash mixed with lime and seawater created a mineral called aluminous tobermorite. When tiny cracks form in the concrete, it reacts with water to create calcite, which helps seal the cracks. The good news is that scientists have found a way to replicate the same process. In 2023, researchers replicated the process that creates the healing mineral in the lab. Cracks as wide as 0.3 millimeters were fully sealed in just 2 weeks. This discovery could mean that soon we will see bridges that heal themselves. Bridges that don't need frequent and expensive maintenance. Bridges that can resist the effects of corrosion and erosion. And yes, better bridges would mean that we won't be spending as much money on rebuilding and maintaining them. But let's not get ahead of ourselves. This might seem like the answer to all of our problems, but it's not. The biggest problem with concrete right now is that it just needs more resources to produce it. New cement plants and ready-mix plants must be built, and materials need to be transported to these locations. Also, we would need to get a lot of funding to start up this process. But with a little ingenuity and time, who knows? Maybe we can put ancient techniques to work for us in the future. Curiosity? What about air conditioning without electricity? The summers in Iran can get pretty hot, reaching temperatures of around 40 degrees Celsius. In the Yaz province, the local people have been living comfortably in houses with courtyards and windcatchers for 3,000 years. But how do these simple stone towers keep their owners cool when the outside temperatures can reach deadly levels? Windcatchers are placed on top of buildings and used in tandem with underground water channels called queues to maintain a comfortable temperature inside of homes. The underground queues allow for a constant supply of cool air from deep within the ground, where the temperature remains steady year-round. The windcatchers use airflow dynamics to draw the cool air through the home and push warm air out. Warm air rises and exits through the tower, while cool air sinks and enters the home through strategically placed vents. As the air descends, it evaporates moisture from the qanat, dropping the temperature as much as 10 to 12 degrees Celsius. The best part is that the entire system runs on its own without any moving parts, meaning it requires no electricity. Modern air conditioning accounts for 6% of the world's electricity consumption. If we had a cheap and efficient way to mimic these natural principles, we could dramatically reduce our reliance on fossil fuels and lower our carbon footprint. A recent project in Dubai in 2022 hybridized traditional windcatchers with solar panels to further reduce energy usage. Solar panels placed on rooftops heated water, which circulated through the walls and provided passive heating during the winter months. The building used 30% less energy compared to other buildings in the area. Now that's some serious innovation. Just imagine how many lives could be saved if we implemented this technology on a larger scale. And yes, you will need to have some initial investment, and yes, it would require digging large canals and building windcatchers. But it could potentially cut down on the amount of fossil fuels we use and decrease the cost of running your air conditioner. That's a win-win in my book. But how did ancient civilizations master time? One of the greatest inventions of ancient Egypt was the clepsydra, also known as a water clock. Egyptians developed this device around 1500 BC, a full 3,000 years before the invention of the mechanical clock. The Egyptians used the clepsydra to divide the day into 24 hours. The Egyptians had a surprisingly accurate understanding of astronomy. The problem was that they didn't have a way to track time accurately. Enter the clepsydra. There were many types of clepsydras, but they all worked on the same basic principle. Water flowed from one container to another at a steady pace, and the amount of water that flowed indicated the time elapsed. Water clocks lost only 15 minutes a day, which was pretty accurate for the time. Physicists at CERN's chronometry team are studying the geometry of ancient water clocks. They believe that the shape of the containers used in the clocks could have a significant impact on the flow rate of the water. The team has created a series of computer simulations to test various shapes and sizes of containers and how they affect the flow rate of water. In 2021, the team released the results of their research. They stated that the key to the success of the water clock was the use of tapered containers. This helped regulate the flow rate of the water and ensured that the clock remained accurate. Researchers hope to use this knowledge to improve hydroelectric turbines, which are used to generate electricity from flowing water. The new design, based on ancient Egyptian principles, could lead to a significant increase in efficiency and energy production. But what about fire? The Byzantines weaponized fire. Imagine sailing around the Mediterranean Sea in the 7th century AD. Your Byzantine ship is engaged in battle with the Persians. Suddenly, a fiery liquid starts raining down on you from the sky. You try to protect yourself, but it's no use. You've been hit by Greek fire. Greek fire was a powerful incendiary liquid said to have been used by the Byzantine Empire between the 6th and 12th centuries. The exact formula of Greek fire has been lost to history, but we know that it burned fiercely on water and was delivered via a pressurized pump system mounted on warships. Today, similar substances are being studied for use in compact energy storage. Think batteries that could release energy on demand. In 2023, scientists conducted tests of a substance similar to Greek fire. They wanted to determine if it could be used as a highly efficient fuel. The results were promising. The substance showed a 20% increase in energy density compared to lithium-ion batteries. The military is currently bidding against the electric vehicle industry to use this technology first. While the military wants to use this technology for new weapons, the EV industry sees it as a way to improve battery efficiency and range. There are many things that we can learn from the ancients, whether it be the pyramids, Machu Picchu, or the Colosseum. These ancient structures are a testament to human ingenuity. Not only were they built without modern tools or technology, but they have stood the test of time. If the ancient civilizations could build these structures without the help of modern technology, then who knows what they could invent? What if the Chinese predicted earthquakes 2,000 years ago? In 132 AD, Chinese inventor Zhang Heng created a device that could detect earthquakes hundreds of miles away. His invention, known as a seismoscope, consisted of a bronze dragon seated on a turtle with a ball suspended from its mouth. When an earthquake struck, the ball would fall into a container shaped like a frog's mouth, indicating the direction of the tremor. To understand how this device worked, let's break it down. Inside the dragon's mouth, there was a pendulum attached to a hook. The pendulum hung down and rested on a small ball. When an earthquake shook the building, the pendulum swung and the ball rose. Once the ball reached a certain height, it left the hook and fell into the frog's mouth. Different frog mouths were positioned to indicate different directions. The device was able to detect earthquakes up to 500 kilometers away. Geologists are studying this ancient technology to develop new ways to detect earthquakes. They believe that the mechanism behind the seismoscope could be used to create more sensitive seismic sensors. Sensors that can detect earthquakes earlier and more accurately could save countless lives. In 2021, a team of scientists in Japan built a replica of Zhang Heng's seismoscope and tested it. The device was able to detect earthquakes 10 seconds faster than current technology. Even a few seconds can make a huge difference when trying to evacuate an area before an earthquake hits. Imagine being able to feel an earthquake coming before you even realize it's happening. Well, that might be possible thanks to the ingenuity of the ancient Chinese. That's all for now. See you next time.